The behavioral design pattern called chain of responsibility is one that is used pretty heavily in UI programming, actually. But it's not just limited to UI programming. It could actually be used anywhere where the best responder will deal with a specific circumstance. Now, what I mean by that is you'll have a chain of classes that are tied together, and they will each have a common method. Maybe we'll call it process. And essentially what happens is this data is passed to the process method of each of these classes. And if that particular class is able to handle that data correctly, then it will. Otherwise, it will pass the responsibility on to the next class until you run out of classes in the chain. Now, I mentioned it's used in UI heavily, and if you think about it, when you design a user interface, you have a layer of controls. You have, in this case, like a text box sitting on top of a div, on top of another div, on top of the body. And so you have this hierarchy from high to low. And when you click on something, the interface tries to let the highest most control deal with that event. So if I click on this text box, it says, text box, here's an event, I need you to deal with it. If it can, it will. In this case, it did. I clicked it, and now the cursor is flashing inside there, etc. But if it wasn't able to handle it, then it would pass responsibility to its parent, and then to its parent all the way up until there is no more parent. And if nothing's able to handle it, then it's an unhandled event. Okay, let's get started by, first of all, I'm going to import some methods from the math module. I'll import square root and floor, and you'll see why momentarily. Because I'm going to create a chain of event handlers here that will look at whether or not it's able to deal with a specific number. And they will be defined as whether or not, if it's a prime number, this particular one can deal with it. If it's an odd number, this one will deal with it. If it's an even number, then this one will deal with it. Otherwise, there's nothing that can deal with it. So first off, we need a base class. And I'll call this handler base. In essence, this is going to be the glue that holds everything together, and since this is the base class, all the other ones are going to derive from it. So we need to define some basic functionality in here. And I'm going to create this chain2 object. I'll set it equal to none. That is going to indicate if this class is unable to handle the data, I need to pass responsibility over to whatever is chained to. This is the base class. It actually can't really do any processing, but I still want to set up the template because all the derivatives are going to follow the same process. And it's just going to return false. It is unable to process it, so we will say it is unable to do it. We'll have to pass it on to someone else. Okay, so let's define our next class, and we'll call it prime handler. And it is also a handler base. So we're deriving from handler base. And then we'll define the init, and it will also have that chain2 value. We'll set that equal to none. So I'll access self.chain2. Oh, we forgot the underscore there. And we'll set that equal to chain2. as such. So this will allow us to assign the thing we're chaining to that chain2 variable that the superclass or the base class knows about. Then I'm going to define a function in here called isPrime. Now that's not the point of the lesson, so I'm just going to paste that in here. This just indicates whether or not a number is prime. Okay. Then the piece that is important for this demo is this process function. This is the thing that's going to indicate whether or not this class is capable of handling the value that was passed in. If not, that's where it has to hand off responsibility to some other class. So say if self.isPrime value print when possible, be dynamic. So we have class name, handled, request, I'll put value. Okay, we're just going to indicate we're able to process it, and then some action would happen here. So maybe saves it to the database, prints it to the screen, whatever, and it's going to return true. Else, if self.chain2 actually points to something, then we'll return self.chain2.process value. And if it has nothing to pass it off to, it was the last one in the chain, I can't handle it, no one else can handle it, time to return false. So that is really what we're looking for right here, is this process method. It determines whether or not it's able to handle it. If it is, it deals with it and returns true. If it can't, it checks to see if there's anything else in the chain for it to pass responsibility to. Otherwise, there's nothing left. All we can do is return false. Now, we're going to create several of these classes, and rather than have you watch me do a bunch of typing, I'm just going to fast forward here and paste some code for the even handler. So we have a prime number handler, now we have an even number handler, and as you can see here, the init is virtually the same. Then instead of an isPrime, I have a function called isEven. Now for something like determining if a number is even, I really didn't need to create a function here, but I'm trying to be consistent in all of my classes so they follow a pattern. So we had isPrime, now we have isEven, and then we have process. And if you look at the process method, it is going to be virtually identical, except for this piece here, except we're calling isEven instead of isPrime. And again, if it can't handle it, it tries to pass responsibility to another class. We'll insert one more cell because we need an odd handler. And again, it's virtually identical. The only difference is we're checking for even. We're not going to allow 0 to be even. But everything else that's evenly divisible by 2 is even. This one's checking to make sure it's not divisible by 2. And if it's able to handle it, it does. Otherwise, it passes responsibility or returns false. So let's put these to the test, and I'll show you how this works. So we'll say handler is equal to prime handler. Notice here, that's how I started it, with prime handler, the most specific one. And the reason I have to use prime handler first, as the first one in the chain, is because there are odd and even numbers that are both prime. The only even number that's prime is 2, but all the other prime numbers are odd. So if we started with odd handler, we would never be able to see if prime handler would trigger. So basically, it would never return anything for prime handler. So we start with the most specific one, and then we start putting in the less specific ones. And notice we're calling the constructor each time, so we call the prime handler constructor. And that one we're passing the constructed value for even handler. And for even handler, we're going to pass it the constructor for odd handler. Let me put that in here. So the order of the event handling will be, it'll check for prime handler first. If it can't handle it, event handler, or the even handler, will be the next one in the chain, followed by odd handler. Let's create a value, and we'll set it equal to 257. And we'll say result is equal to handler.process value. And then we're just going to have something that indicates if it was handled. So, was the value handled, true or false? Remember, if it is handled by a specific one, it'll let us know by printing it from the process method of that handler. And we're just going to repeat this for several different values. We'll have 257, maybe we'll have 300. Let's do negative 121. And let's throw a 0 in there because we know we can't handle a 0. And maybe what I'll do is I'll put a divider between them. I'll just make it easier to read. Okay, so let's run all of these cells. So run, 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 run. So all the handlers have been compiled. Let's run it. So here we go. 257 was passed in. Prime handler handled request 257. And then we get this response here. Was 257 handled? True. Even handler took care of the 300. Odd handler took care of negative 121. And then was 0 handled? No. So you can see here we have one handler that links to two others. Prime handler links to even handler, links to odd handler. And then it handles all these values appropriately. Now, what happens if I took prime handler and I put it inside here? And the copy didn't work. Okay. I need to get rid of one of these. Now, prime handler will happen after odd handler. As I said before, because odd handler can handle 257, I would expect that prime handler will never indicate that it did anything. And that's because it hasn't. Prime handler was never given the opportunity to, because odd handler took care of the prime numbers. So I'll undo that, because this is the order we want. Now, as far as the even and odd handling is concerned, those are interchangeable because the sets are mutually exclusive. But it is entirely possible we could have another one to see if a number's in the Fibonacci sequence. Well, that one's going to step on both even and odd numbers, so you'd want that in front of the even handler, and you may even want it in front of prime handler, depending on whether you consider prime numbers more important than Fibonacci numbers. So there are several different ways you can accomplish that. Now, instead of returning true or false from the process event, we could actually return a tuple indicating yes, it's true or false, and then we could pass a reference to the object indicating which one handled it. But in this case, this is probably adequate. And let's say the idea is you have data that needs to be saved, and the chain of responsibility is first check to see if it needs to be saved to a database. Next one, is it to a flat file? The next one, is it to the internet? And it has to go through the list. Depending on the data, it has different places to store it. So that would be another example of how this could be tied together.